I'm back. I just wanted to take a second at the start of this video to thank you guys. Okay, we finally hit 11 subscribers, and I never thought that that could happen. Alright, so keep smashing that like button, keep hitting that subscribe button. Maybe we'll hit 20 sometime. Okay, just wanted to say thank you. Shout out to my fans, appreciate it. Alright, now the reason you guys are here are probably for the Matrices Notes, so let's get on with that. Okay, so Matrices Notes. What are matrices? What does that even mean? Okay, matrices is the plural of matrix. Okay, so multiple matrices is pronounced matrices. Alright, what is a matrix though? A matrix is a rectangular array of numbers such as this and that. Alright, there's no good way to read that out loud. Okay, a matrix is just putting numbers in rows and columns basically. Okay, so in this case we have 2 rows and 3 columns. Rows are going across, 2 rows, 3 columns, columns are going down. Okay, so we write that 2 by 3 columns, rows by columns. Okay, so this one has 2 rows and 1 column, so we would write that 2 by 1. Alright, that's just a little background, not super important, but if that ever shows up, you at least know what they're talking about. Okay, and we use capital letters to name matrices. Okay, so when we refer to a matrix like this one, sometimes we might write something like A equals that. So anytime we want to refer to the matrix that's right here, instead of writing this whole thing out, we can just write A. Okay, or that is B. Okay, we can just name them anything with a capital letter. You guys don't have to write that in. I just wanted to give an example. Alright, so why are we even learning matrices? What does that have to do with anything? Well, matrices are very helpful in systems of equations. So the stuffs we've been doing, where we have like a 2x plus 3y equals 6. We have 2 equations, both using the same variables. It's a pain in the butt to solve, and I get that. And that's why we're learning this right now, because we can use them to solve any system with the help of a calculator. Okay, so finally we get to use our calculators to make something real easy for us. Alright, so for example, here's the system. It's 3x minus 7y equals 4 and 2x plus 5y equals negative 2. Okay, so pretty standard. There's no good way to solve it from what we know though, because substitution would be awful, trying to get a variable all by itself. Nobody wants to do that. And elimination would kind of be a pain, because in this case we'd actually have to multiply both of our equations. Okay, we can't multiply the bottom one by anything to get 3 here or a 7 here. It would just be a pain. We would have to do a bunch of extra steps. So that's where matrices comes in handy. Alright, so we're going to end up filling in these matrices. This one is 2 by 2, this one's 2 by 1, this one's 2 by 1. But let's figure out what we're going to put in them first, and that's going to help us solve it. So A is going to be our coefficient matrix. Coefficient matrix. Okay, so that's just pulling all the coefficients out of this. Remember, the coefficient is what we multiply our variable by. Okay, so in this case our coefficients are 3, negative 7, and we're just writing them exactly where they are. We can really cover up the rest of this and just put those numbers in. 3, negative 7, 2, 5. So 3, negative 7, 2, 5. It's that simple. Alright, and then moving on, B, that's going to be our solutions matrix. Okay, so 4 and negative 2. Whatever this stuff is equal to. 4, negative 2. So as we read this across from A to B, we have all of our numbers. We have 3, negative 7, 4, 2, 5, negative 2. Okay, it looks just like that. And X is actually just going to be our variables. X and Y. Variables. So matrices are unique in that they have like a totally different set of rules for how they work. Like multiplying matrices, adding and subtracting them, it works way different than we might do with just standard numbers. Okay, because 7 times 4, for example, I'm just do this on the side just to explain this. Let me do something easier. 2 times 3. That's 6, right? And 3 times 2 is also 6. Okay? But in this case, if I wanted to do like A times B, that is not the same thing as B times A. Okay? That's called commutativity. You don't need to know that word either. I'm just pointing out the fact that like the multiplication rules for matrices work way different than they might do with normal numbers. Okay, so we got to be careful when we're trying to deal with them algebraically. We really won't be dealing with them algebraically. It's almost all going to be in the calculator, so don't worry too much about that. But it's just something to keep in mind. They work a little different than you might think. All right, A times X equals B. Okay, that's just the way matrices works. If I said A times X equals B with these letters, with these matrices, that says the exact same thing as this. This is just another way of saying that, what our original system of equations said. Okay, so this is just a new way of writing it. After some algebra, if you have A times X equals B, the more important relationship is X equals A inverse times B. This right here, do whatever you got to do to remember that. Okay, X equals A inverse. This -1 means inverse. Okay, X equals A inverse times B. So, therefore, XY, remember this is our X matrix. X, XY. And then A inverse, so we're just going to take A, bring it down, 3, -7, 2, 5. That inverse, we're just going to keep that -1 up there, times B, 4, -2. That's actually going to give us our answers. Alright, so let me show you what that would mean in a calculator. I just made this problem up. I don't know if the numbers are going to come out nice. They very well might not. But let's see how this works. Okay, so go ahead. Let me act like I just restarted this. Okay, turn your calculator on. Press OK. I don't know what that means. Alright, go to calculate. So go to your calculator. You're going to go to menu. It's kind of hard to see. Brutal. Alright, that's probably the best way I could do this. Okay, go to menu. Go down to 7. 7, it says matrix and algebra. I'm sorry, matrix and vector. Okay, go down to that. We're going to pick our first number. It's going to say create. And then again, the first number, matrix. Alright, so what that did was give us a chance to... Jeez, this thing stinks. Alright, once we go over this in class, I'll probably be able to explain it better out loud. So I'm going to skip that explanation part for now. I'm just going to punch this stuff in. We punch in the matrix in the calculator. We figure out the rows and columns. We can type in 3, -7, 2, 5, which is just what our A is. Okay, all we're doing is typing this in, take that, and then raise that to the -1 power, because it's the inverse. Okay, and then we press times. We're going to multiply it by this little baby matrix. Okay, so go back to menu, go back to matrix and vector, and then create, and then matrix. So menu 7, 1, 1. Alright, here we have 2 rows, but we only have 1 column. So go ahead and type in 1 instead, and then go down to OK. Or we could type in 4, -2. And now that we got all that stuff typed in, we can just press enter. It gives us some really ugly numbers. I'm sorry they came out this way. But it comes out 6/29 and -14 29ths. Okay? Solving that by hand would have destroyed us. We do not want to solve this by hand. And that's what matrices are for. When we get really ugly numbers, or honestly, even if they're easy numbers, we can just plug this stuff into a calculator. It's going to give us the answer. Because of math. Alright, I don't want to get into the deep details why, but it's because of math. Okay, so let's try another example. Here we have even worse numbers. 20, 13, and 46. That sounds awful. We don't want to have to do that. So let's go ahead and use matrices. Remember, we take our coefficients first. -2. The coefficient on y is implied. It's just 1. Okay, if you have just a variable alone, your coefficient is 1. Okay, and then 20, 13. All right, now our solutions matrix, we're taking our last two numbers, so 12 and 46. And then our variables matrix is x and y. It's almost always going to be x and y. Sometimes you'll get letters like A, B, and C, depending. But in this case, x and y. All right, again, x equals A inverse times B. This is very important, okay? If that's true, then our x matrix, which is xy, equals our inverse of A, so negative 2, 1, 20, and 13, inverse, times our B matrix, 12, 46. All right, we can type this back into our calculator. You can go through that whole process again, or you can go to the last matrix and just re-enter some of this stuff. So negative 2, 1, 20, 13, and then the inverse. Don't forget the inverse. That is the most common mistake with using these in the calculator. Do not forget the negative 1. Okay, and then 12 and 46. And we get even worse numbers. Negative 55 over 23 and 166 over 23. So thank God we get calculators on these. All the ones I've been giving you have been very simple, maybe a fraction here or there. But now we can deal with any matrix. Now we just got one more example on the back here. This one's kind of ugly. Again, this was on the quiz we just took. This is disgusting. We do not want that. Okay, we want to rewrite this. So we want our x to be first, and then our y, and then our equal sign, and then our constant. Okay, so this x is in the wrong spot. We got to move it. We'll subtract it from that side, and it's going to end up on this other side. So now we have negative x. Next comes our y. Our y is already over there. We don't have to change anything. We just put minus 2y. And then equals, and our 4 is already on the correct side of our equal sign, so we just leave that alone. Negative x minus 2y equals 4. Okay, and now second, our x is already in the right place, but our y is not. Okay, so we got to subtract 3y from both sides. Minus 3y. And then equals, and now our 3 is on the wrong side. So we got to add 3 to both sides, and we get x minus 3y equals 3. All that we're doing here is if something is on the wrong side, we just flip it to the other sign. So if it's negative, it becomes positive. If it's positive, it becomes negative, and we put it on the correct side. That's all that process is. And the reason we had to do that is matrices do not work unless everything is in this order. X, Y, constant. X, Y, constant. We need to be able to get it to this form because this would not pan out well. All right, so let's fill this in. Negative x, the coefficient there is negative 1. Negative 2y, our coefficient is negative 2. X, our coefficient is just 1. And then negative 3y, our coefficient is negative 3. Alright, our solutions matrix, B, is just 4, 3. And then our variables, again, are x, y. Okay, we're almost done here. X, y equals... Then we rewrite A, negative 1, negative 2, 1, negative 3. We take that to the negative 1 power, and then times 4, 3. Let me punch that in the calculator. This is our last one. Hopefully the numbers work out better. I think they will. Again, I just made this up. Who knows? Alright, just typing this stuff in. We get negative 1. And then we got negative 2. And then we have 1 and negative 3. All that to the inverse times 4 and 3. Type that in. Still fractions, but not as bad. We get negative 6/5 and negative 7/5. There you go. Now we can deal with really ugly numbers using matrices and not work very hard doing it. Okay, again, thanks for watching, thanks for subscribing. Real hyped to make the next video, guys. Follow me on Instagram, on Twitter, donate to my Patreon. Just keep this channel alive. I appreciate it, guys.